Quantum physics, the nature of reality and the limits of human understanding. Quantum physics, the branch of science that studies the behavior of matter and energy at the smallest scales, has revolutionized our understanding of the universe. But beyond its scientific implications, quantum physics challenges our most fundamental assumptions about reality, causality, and the nature of existence. It forces us to confront the limits of human understanding and raises profound philosophical questions about the nature of the universe and our place within it. Number 1. The quantum revolution. At the turn of the 20th century, classical physics, rooted in the deterministic laws of Newton and the electromagnetic theories of Maxwell, could not explain phenomena at the atomic and subatomic levels. The birth of quantum mechanics, pioneered by scientists like Max Planck, Niels Bohr, and Werner Heisenberg, introduced a new framework that defied common sense and challenged our intuitive understanding of reality. Wave-particle duality. One of the most striking features of quantum physics is the dual nature of particles, which can behave both as particles and waves. This duality suggests that the nature of reality is far more complex and ambiguous than classical physics had assumed. Quantization. Quantum physics reveals that energy is not continuous but comes in discrete packets called quanta. This discovery fundamentally altered our understanding of the physical world and laid the groundwork for modern technologies like semiconductors and lasers. Number 2. The uncertainty principle. One of the cornerstones of quantum mechanics is Heisenberg's uncertainty principle, which states that it is impossible to simultaneously know both the position and momentum of a particle with absolute precision. This principle introduces an inherent unpredictability into the fabric of reality. Philosophical implications. The uncertainty principle challenges the classical notion of a deterministic universe, where every event is governed by precise laws. Instead, it suggests that at the quantum level, reality is probabilistic and uncertain. This raises questions about free will, causality, and the nature of knowledge. Observer effect. In quantum mechanics, the act of observation affects the system being observed. This phenomenon has led to debates about the role of consciousness in shaping reality. Does the universe exist independently of observers, or is it somehow dependent on our perception? Number 3. Quantum entanglement and non-locality. Quantum entanglement is a phenomenon where two or more particles become correlated in such a way that the state of one particle instantly influences the state of another, regardless of the distance between them. This spooky action at a distance, as Albert Einstein called it, challenges our understanding of space and time. Non-locality. Entanglement suggests that the universe is fundamentally interconnected, with particles sharing a deeper level of unity than classical physics can explain. This has led some to speculate about the existence of a hidden reality beyond our current understanding. Philosophical questions. Does entanglement imply that the universe is holistic rather than composed of separate parts? Could it provide a scientific basis for concepts like interconnectedness and oneness, often discussed in philosophy and spirituality? Number 4. The measurement problem. One of the most perplexing aspects of quantum mechanics is the measurement problem. Why does a quantum system appear to collapse into a definite state only when observed? This problem has given rise to several interpretations, each with its own philosophical implications. Copenhagen interpretation. Proposed by Niels Bohr and Werner Heisenberg, this interpretation suggests that quantum systems exist in a superposition of states until measured. It emphasizes the role of the observer in determining reality, but leaves many questions unanswered. Many worlds interpretation. This interpretation, proposed by Hugh Everett, suggests that every possible outcome of a quantum measurement actually occurs, resulting in a branching of parallel universes. While it avoids the need for wave function collapse, it raises questions about the nature of reality and the existence of infinite parallel worlds. Pilot wave theory, also known as the Bohmian interpretation. This theory posits that particles have definite positions guided by a pilot wave. It reintroduces determinism into quantum mechanics, but at the cost of introducing hidden variables. Number 5. Quantum physics and the nature of reality. Quantum physics challenges our everyday notions of reality, forcing us to reconsider what is real and how we can know it. Objective reality. Does an objective reality exist independently of observers? Or is reality somehow dependent on observation? Quantum mechanics suggests that reality may be more fluid and observer-dependent than we once thought. Causality. Classical physics assumes that cause and effect are straightforward and deterministic. Quantum physics, however, introduces randomness and probability, raising questions about the nature of causality and whether events are truly predictable. The limits of knowledge. Quantum mechanics reveals that there are fundamental limits to what we can know about the universe. This echoes philosophical ideas about the limits of human understanding, as discussed by thinkers like Immanuel Kant. Number 6. Quantum physics and consciousness. The relationship between quantum physics and consciousness is a topic of intense debate and speculation. Some theorists, like Roger Penrose and Stuart Hameroff, propose that quantum processes in the brain may play a role in consciousness. While this idea remains controversial, it highlights the deep connections between physics, philosophy, and the study of the mind. Quantum mind hypothesis. Could consciousness arise from quantum phenomena in the brain? This hypothesis challenges traditional views of the mind as purely classical and opens up new avenues for exploring the nature of consciousness. Observer effect. If observation affects quantum systems, does this imply that consciousness has a fundamental role in shaping reality? This idea has sparked both scientific inquiry and philosophical speculation. 7. Conclusion. A new understanding of reality. Quantum physics has transformed our understanding of the universe, revealing a reality that is far stranger and more complex than we ever imagined. It challenges us to rethink our assumptions about determinism, causality, and the nature of existence, while also raising profound philosophical questions about the limits of human knowledge and the role of consciousness in the universe. As we continue to explore the quantum realm, we are not only uncovering the secrets of the physical world, but also deepening our understanding of the philosophical questions that have puzzled humanity for centuries. Quantum physics reminds us that reality is far more mysterious and wondrous than we can comprehend, and that the journey of discovery is far from over.